Greetings, dear friends, fellow programmers, and those aspiring to be. Today, we are going to be diving into the fascinating world of JavaScript, exploring a very important core concept that lies in the core of the programming language and defines how functions are going to be executed. So, if you would like to be completely certain which function is going to be executed when in your code, you are in the right place, my friend, because now you're about to learn how everything works under the hood. In JavaScript, in order to completely understand the order of execution of functions, you need to be familiar and have a firm grasp on the concept of call stack. The call stack is something like a roadmap that allows interpreter of JavaScript to always be aware of the fact which function should be executed next, which practically means that call stack plays a crucial role when it comes to the execution process of our application. The call stack is basically like a backbone of JavaScript because it defines core behaviors that are going to be taking place, which is exactly one of the main reasons why on the interviews that I've attended throughout my lifetime, I've stumbled upon this topic many times, both in theory and in practice, with some very simple examples that are going to test whether you understand the call stack and how things are going to be executed and in which order. And if you want to ace those interviews, you just need to sit back and enjoy this video and you will be able to ace them for sure. Now, here things might become a bit tricky for some, and mostly that is for beginner developers, because visualizing how functions are stacked one on top of the other might be something that you can build up confidence with over time. But do not worry, I'm about to explain this concept in a bit more detail. So, first of all, call stack is a data structure that works as a stack. So, if you're familiar with data structures, you will know that stacks are basically last in, first out data structure, which means that the last item that was added to the stack is going to be the first one to be popped from its top. So when you're stacking things in stack, you will never be able to fetch the one from the bottom. You will always be fetching from the top. So the last item that was placed in the stack is going to be the first item you have to pull out in order to access the one under it. And now let's go back to our JavaScript discussion. So each time a function gets invoked in JavaScript, it gets put on top of the call stack. And every time it returns a value, it gets popped off the top of the stack. So once you push a new function that needs to be executed on our call stack, it stays there as long as it returns its value and it is done executing, which is when it gets popped off from our call stack. But the best way to understand this is, of course, in action. So let's head out to our IDE and see what I'm talking about. Right here, I have prepared a very simple example for you, which is going to demonstrate very well, at least I think, how call stack works. So we have three functions, and after they are defined, we just invoke the first one. Now, I would like you to pause the video and think about what is going to be printed and in which order. So 3, 2, 1, pause now. Okay, welcome to our drawing board. It is time for me to explain what is going to be happening inside of JavaScript's engine once we start executing our code. So, as you already know, this right here is the code we will be executing. And once we run our JavaScript code, the following stuff is about to start happening. First of all, as you probably know, the process of hoisting is going to take all the variables and functions and push them to the top of execution, and then basically it will know that those functions actually do exist. And then when that is done, it will proceed and start executing stuff. So as we can see in our code, the only function that we actually invoke is the first one. So once we have started the code, the first function is going to be executed. Once that happens, it will be pushed to the call stack. So we will just draw our first function right here. And once we have done that, the first console line that is on the top of our code is going to be executed. That way, we will receive first function message in our console printed first. But after that, we can see that the second function gets invoked, which means that the first function is still not done executing, but we have invoked the second function, which means that it will be pushed to the call stack as well. As you already know at this point, call stacks are basically stack data structure, and when it comes to stacks, they are first in, last out type of structure. So that means that the stuff that goes in first is going to get out last. And now that we are pushing the second function onto our call stack, it will be put on top of the first function. So basically, it will be dropped on top of our function 1. Such a beautiful handwriting, right? So now when that happens, the second function will start executing. This will mean that its first console log will be executed, and we will receive second function message in our console. And once that is done, we're invoking the third function. So the same exact thing is happening once again. We're pushing the third function onto our call stack, so it will be pushed on top of the second one, so right here, and it will start executing. This will mean that we print the only console log that we have from the third function into our console. That means that we have executed everything from the third function that needed to be executed, so we can remove it from the call stack. That means that the third function will be popped off the stack, so we no longer have it. Right now, the second function is on top of our call stack, and basically, once that function number 3 is done executing, we will return to the point in our code right here where it was invoked in our code, and then the second function will keep executing. That means that we will then print the end of second function message to our console. And once that is done, everything from the second function is done executing, which means that it can as well be popped off the call stack. So it will be popped off the call stack and we can just cross it out, which leaves us with only first function in the call stack. And we will be going back into the execution of the first function exactly where the second function was invoked, which is right here. And once we are there, we can see that we only have to print the end of the first function message to our console. Once that is done, we can simply remove the first function from the call stack, so it will be popped off also, and we are completely done. Our call stack is completely empty, which means that our application is done with its execution. And there you have it, folks. Now back to Marko sitting in the chair. Bye! And now that we finally understand how call stack works, I think it's a great moment for me to ask you a simple question. What do you think is going to happen when an error occurs in JavaScript code? And of course, this is one more case when call stack is extremely beneficial, because when an error occurs, call stack is going to allow us to completely be able to go back through time and see where the function that threw an error was invoked from in the beginning. That way, you can go back in your code and find exactly at which location the problem began. Let me show you an example. So, as you can see, we have a very simple example right here. We have three functions, 1, 2, and 3, and each one of them is calling the next one. So we're invoking function 1, then function 1 invokes function 2, then function 2 invokes function 3, and function 3 throws an error. So what do you think is going to happen when I run this code? Let me give you an answer. Let me show you the answer. So first of all, we can see that an error is thrown and we can see the message that we used. But what I care more about is this part right here. So as you can see, at function 3, line 30, so this line right here, we saw the error happen. But at function 2, at line 26, is where this method was called. But then at function 1 at line 22, this function was called. So basically the call stack is going to be popped for you in order to show you exact calls that are being executed, and that way you can go to the beginning of the call stack and see exactly where things started. So that's another very useful thing where you can use call stack. And I would like to mention one more issue where you might encounter a problem because of call stack. And if you understand call stack and how it works, you should be able to handle this issue with ease. So when you think about it, call stack is just a data structure that is being used by JavaScript's engine to put inside of it all the functions that are supposed to be executed. And it just pushes and pops items from that stack when it needs to. But just imagine the scenario where you've made a mistake or whatever, and you have a scenario where you want to push a lot of items into a stack before you pop anything from it, and you encounter a dreaded stack overflow error in JavaScript. This is going to happen when, for example, you create a recursive call within a function to itself. Let me show you an example. So this is exactly what I was talking about. As you can see, recursive function is calling itself, and there is no break condition to get out of this method. So this is going to be executed endlessly. In theory, but in practice, it's going to be executed as many times as your call stack has places inside of it. So when I run this, of course, we get an error, which is going to say maximum call stack size exceeded. And you can see that we are constantly invoking recursive function over and over again. So basically, this is something you need to be very careful about. And if you do something like this, it is basically going to be greeted by a range error from JavaScript, which basically in reality means you did something stupid and you did not know you did something stupid, so please fix it. That is exactly what you need to do in those situations. To wrap things up, call stack is a core concept in JavaScript that basically tracks which function is supposed to be executed next. It keeps track of the execution order of all the functions in our code. And of course, by mastering this concept and truly understanding it, besides acing those interviews, you will be able to understand your code and find potential issues with it much easier, and basically you will feel like a true boss because you knew how call stack works. If you found this video useful, I would like to invite you to hit that subscribe button and turn the notifications on so that way you will not miss the next upload, which is again going to be dedicated to one of the core concepts of JavaScript. So until the next video, I would like to thank you for watching and wish you an amazing day.